is a subgroup of your group G, of your big group G. Okay? And now the exercise is, this is the last exercise of the problem-solving part of this lecture, is to prove that. Prove that the centralizer, this Z of G here, is a subgroup. Okay? So once again, we go through the same procedure. We test for a subgroup. We test for closure, that there's a unit, and that there are inverses. There's an inverse for each element of this set. All right. So let's do that. Let's see. So we have to prove closure. So what does that mean? So for any two elements Mn that belong to Z of G, right? We have to show that Mn belongs to Z of G. Okay, that's what we have to show this. In other words, now if Mn does belong to this, what that means is that this Mn commutes with G. Follow that? So see, if this Mn belongs to this set, it means that Mng equals Gmn. So we have to show that Mng equals Gmn. That's what we have to show. Okay. All right. How to do that? Now look, M belongs to the centralizer. N belongs to the centralizer. So this implies that Mg equals Gm, right? Because M belongs to it. N also belongs to it, so therefore Mg equals Gn, we know that, okay? Now we can use that here. So we have to show that Mng equals Gmn. We have to prove that. Okay, so let's play with this and use these. So Mng, now Ng, look, Ng is Gn. So that's Ngn, right? Ng equals Gn. That's because N belongs to the centralizer. N belongs to this set. Okay? Now Mg is Gm. So it's Gn. And there it is. So Mng equals Gmn. So we've proved it. So therefore Mn here, Mn belongs to the centralizer. Alright? Therefore, Mn is, therefore this, the centralizer, this set is closed. Okay? Because any Mn gives you, any Mn belongs to this set. So it's closed. Right. The unit. Well, let X be E. Okay, let X be E. So EG is GE. That works. Therefore E belongs to Z of G. Okay? So just the unit of the group belongs to this set. Okay, so E belongs to it. Alright, so we have a unit. Now how about the inverse? The inverse. How to prove that? So we have to prove, so for all X belonging to Z, show that the inverse belongs to Z. Okay? And if that's true, that means that X inverse G equals G inverse X. Okay. I'm forgetting. Hold on, I'm forgetting how to do that. I did this. Right. Just looking at my notes. I was solving this a bit before. Okay, so so we want to prove that x inverse G equals G x inverse. And we want to do that because we want to show that the inverse belongs to this set, belongs to the centralizer. So we don't know what this is. Just let it be y. And so let's now try to prove. Let's try to prove that y is equal to G x inverse. Okay. That's what we're trying to prove, that's that. Now, we don't know what y is. Okay, now pre-multiply it by x. So you get x inverse G equals xy. Okay. So this is just EG equals xy. So that's just G equals xy. This won't be dry, so I'll do this. I'll go here. Okay, so let x inverse G equal y, and this time I'll follow my notes more closely. Okay, multiply on the right hand side by x. Okay, now gx is equal xg, right? Gx equals xg, so we can swap this around. So this becomes xg equals yx. Now x inverse x is just e, so this is just g. Okay, so g is yx. Now, multiply on the right by x inverse, so you get G x inverse equals y x x inverse, which is just ye, which is just y. Okay? So, this y here is equal to Gx, so that's Gx inverse. Okay, this y here, go back to here. So y equals that, but y also equals this. Therefore, x inverse G equals G inverse x. Okay, so the inverse commutes with G. The inverse commutes with G. So the inverse commutes with G. Therefore, x inverse belongs to your Z, the centralizer. Okay? So for each x, you have an inverse. Also belongs to the set. And therefore you have all your inverses. So you've done all three. It's closed, you've got the unit, you've got the inverses. And therefore, this set here, the centralizer, is a subgroup of your group G. And that's true for any G, any little g. So you'll have a whole, for every element, you'll have for every element of your group, you'll have a corresponding centralizer. Okay? And each one of those centralizers is a subgroup. Okay? Now it's a pretty powerful concept, and you can do a lot with it. And in higher level finite group theory, we will. And as I hope you will keep following this for years, you will see. So that's the end of this lecture on subgroups. The next one will be called, this will be lecture 7, so chapter 7 in the textbook, and it will be on the topic of cyclic groups. So they're sort of groups that cycle in some sense. They go through a loop. There's a more technical meaning, but yeah, it's just an introduction. So until lecture 7, I'll see you again.